In recent years, the negative impacts of manual crude oil tank cleaning have led to stricter regulations within the oil industry regarding confined space work involving hazardous materials, as well as environmental protection. For this reason, the demand for safe, healthy, and environmentally friendly tank cleaning solutions has significantly increased. Maayear Global for Petroleum Services has developed an advanced, fully automated system designed for sludge recovery and the cleaning of large fixed and floating tanks, without the need for personnel to enter the tank. This system complies with health, safety, environmental, and quality standards. It is safe for use in hazardous and explosive atmospheres, certified by ATEX, and it provides a significantly safer working environment for employees. Additionally, it reduces tank downtime, enabling clients to reuse their tanks in record time, while achieving an impressive 95 to 98% hydrocarbon recovery rate. The Maayear Global automated tank cleaning system consists of mobile trailers carrying an integrated tank cleaning and oil recovery system specifically designed for large production and storage tanks with floating or fixed roofs, handling heavy crude oil and similar substances. Below, we present a model tank that demonstrates the mechanism of the Maayear Global system in cleaning a floating roof oil tank, ensuring simultaneous, safe and environmentally friendly oil recovery. The pipes, connections, oil distributors and high-pressure jet nozzles are lifted to the surface. All equipment located both on the surface and inside the tank is ATEX certified and approved for use in potentially hazardous areas. The setup and installation of equipment begin in accordance with a comprehensive installation plan pre-approved by the tank owner. Maayear Global automated system is built to meet health, safety, and environmental regulations, ensuring safe operation in potentially hazardous environments. The vacuum, recycling, and separation units mounted on trailers 001 and 002, along with all necessary auxiliary equipment, are prepared and deployed in full compliance with the hazardous area concession regulations. All operators are trained by Maayear Global to operate the system efficiently while adhering to the strictest safety protocols. To eliminate the risk of explosion, nitrogen hoses are connected to the tank. An inert gas, typically nitrogen, is injected into the tank, reducing the oxygen level to below 8%. This level is maintained throughout the entire tank cleaning process. All legs, guide poles, valves and other areas that pose a risk of gas leakage are sealed off to prevent any gas emissions. Depending on the tank's diameter, the appropriate number of jet nozzles is installed on the roof, either through existing openings or new openings created using a water jet cutting machine, which is ATEX certified and approved for use in potentially hazardous areas. Screw pump hoses, oil boilers heat exchanger hoses, and centrifuge pump hoses are extended to the tank's inlet-outlet nozzles. Additionally, a hose is connected from the decanter centrifuge to the jet nozzles mounted on the tank's surface. The vacuum pump on trailer 001 extracts oil from the tank into the vacuum tanks located on unit 001. The extracted oil is then pumped using the gear pump into the oil boiler, which subsequently heats and directs it to the heat exchanger. The heated oil is then pumped back into the jet nozzles, where it is used as a primary cleaning medium to re-liquefy the sludge and facilitate the desludging process, completing a fully closed-loop recycling system. Maayear Global jet nozzles play a critical role in the cleaning process, controlled via a PLC control unit located inside the control room of Unit 001 or remotely via an iPad. What sets the FuelX jet nozzles apart is their ability to be programmed to specifically target areas with higher sludge accumulation, ensuring effective sludge removal. The desludging process continues until all sludge is reliquefied and completely removed. The entire cleaning process is fully automated, and at no point do personnel enter the tank before or during the operation. The system is easily operated and monitored by a small team of trained personnel using integrated, user-friendly PLC control panels. Control room operation. The screw pump is activated to extract crude oil from the tank and pump it into the decanter centrifuge, where crude oil, water, and sediments are efficiently separated. Separation process. The separation process occurs simultaneously as the separation unit continuously processes the extracted material, allowing tank owners to achieve precise separation specifications. Operators have the flexibility to choose between three-phase decanter centrifuge, which separates solids from liquids, or high-speed separators, which provide additional separation of oil and water. If the oil extracted from the hydrocyclones meets the tank owner's specifications, it is directly pumped into the pipeline. If further treatment is required, the oil is diverted to the separation unit, where it undergoes further separation into clean oil solids and water. To optimize solid-liquid separation, the oil is heated using a heat exchanger that precisely regulates temperature. The separated oil is then pumped into the decanter, where solid materials are extracted and deposited into designated containers for further processing if needed. If the remaining oil still contains water and impurities, the oil-water separator effectively removes water from the oil. The oil is then directed to the high-speed separator, where any remaining water and contaminants are eliminated. To further enhance the separation process, the oil is heated again using a heat exchanger, ensuring a maximum recovery rate exceeding 95% of hydrocarbons from sludge, effectively recycling and reusing valuable resources. The clean oil is then pumped into the sister tank or shipping line. Regular laboratory tests are conducted to verify that the separated oil meets the tank owner's specifications. The water extracted from the process is directly transferred to wastewater treatment facilities. At the final stage, the cleaning robot is introduced into the tank and remotely controlled by an engineer from the control room. Once cleaning is completed, the robot exits the tank, followed by the removal of all equipment from the site.